Okay, so hi everyone. We're going to let's begin lah. Okay, we're going to talk about the next part of this chapter. I hope to be able to actually finish this chapter before the year ends or before your final exam. Uh, yes, there is a final exam for you. So please be ready. Yeah, sekolah tutup doesn't mean tiada exam tau. So jangan juga kamu apa jangan juga kamu breathe a huge sigh of relief because there's no exam. Nope, nope, nope. If the Form 5 have to do their exam, everybody else also has to do their exam. So, I hope to be able to cover as much as I can before the final exam, because the final exam, you kind of need the whole chapter lah, okay, to help you with the final exam. But I will talk about the final exam maybe next week or another day. But today I want to finish this subtopic, which is on page 259. Okay, so if you have your textbooks with you, as I mentioned before, please turn to page 259, okay, on your textbooks. And as always, if you are unable to see when I have changed the slide, okay, please let me know. Okay, jangan berdiam diri and then wait for me to stop talking, and then only you ask. No, I don't want to repeat anything again, okay? Because we are being recorded, and I only have 1 hour, and I want to try not to waste that 1 hour, lah. Okay, by all this endless chit chat. Okay, so I am showing you the PowerPoint slide, and the PowerPoint slide, the title is Thin Lens Formula. Okay, so if you cannot see the slide, let me know. If you can see, I'm just going to continue talking. So last week and up to yesterday, okay, we were talking about thin lenses. Okay, thin lenses, and we learned that there are two types of lens, which is the converging lens and the diverging lens. Okay, converging lens are also known as concave because they meet, and diverging lens is known, convex, okay, because they meet, and diverging lens is known as concave because they disperse. Okay, after they pass through the lens, they diverge. Mereka berpisah. Okay, or they kind of get spread out lah. Okay, but yes, last week when we looked at this, okay, when we looked at, I've changed the slide. The title of the slide now is called linear magnification. If you cannot see the slide, let me know. Oh, sorry, what am I doing? Okay, now. Okay, can you see the slide? Oh dear. Can you see the slide? Okay, thank you. So, as I was saying, when we were studying this one, okay, I introduced to you two very important things lah. Okay, we talked about the object height and the image height, and we also talked about the object distance, which is given by the letter U, and the image distance, which is given by the letter V. Okay, and we use these four things to count this thing called linear magnification. How big is the image compared to the object? So if the number is bigger than 1, okay, means it is bigger than the object lah. The image is bigger than the object. But if the number is less than 1 in terms of magnitude, like 0 point something 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 kan, means that the image is smaller than the object. Okay, means it is diminished lah. Okay, so this is what we concluded last week. But what I want you to take away from this slide, which we're going to learn today, is this U and this V. U is the object distance from the object to the lens. V is the distance between the image to the lens. Okay, I want you to remember these two things because the thin lens formula talks about that. Okay, I've changed the slide, by the way. Okay, the thin lens formula talks about the relationship between this U and this V, which actually I hope that by doing the interactive, you would have noticed it by now. There is a relationship that covers up to a certain aspect, up to a certain point lah. Then after that, the relationship tidak boleh pakai. But generally, we can use this relationship. Okay, and the formula that we're talking about, the thin lens formula, is this: 1 over f equals to 1 over u plus 1 over v. Okay, f is the focal length. Okay, focal length. Okay, U, as I said before, is the object distance. Okay, and V is the image distance. Oh dear, what is this? What's happened to my handwriting? Okay, so this is the formula that we need to we are learning today. 1 over F equals to 1 over U plus 1 over V. It is a formula that relates these three things together: the focal length, the object distance, and the image distance. Now we can use this formula only for object distance and image distance. You cannot use this formula for object height and image height. Okay, height kita tidak boleh pakai. Height kita pakai hanya untuk mengira linear magnification. Okay, or object distance and image distance also can use for linear magnification, but for thin lens formula cannot. The relationship is very specific. It's only between focal length, object distance, and image distance. Okay, we don't use height in this case. Now, there is a small problem when it comes to using this thin lens formula. Okay, now last week, when you were doing the interactive, you would have noticed that there are some numbers that kenapa ini nombor negatif ini? Okay, why is the, for example, why is the image distance, why is it negative? Okay, or you know, why is the linear magnification negative? But you guys did it, okay, and I didn't comment about it because I want to talk about this. Okay, now the reason why some values, some F, U, and V values are negative, it is because they follow this rule, and it's a very important rule. Okay, when we talk about the thin lens formula, I think it is in your textbook in page. Oh dear, I don't even remember the page now. This one, page 261. Okay, page 261. Now, when you want to solve problems using thin lens formula, then turn to page 261, you will see this whole thing there. Okay, I am back to my slide. Okay, I am showing my slide again. If you cannot see the slide, please let me know. Okay, so the value of F okay, is positive if we are talking about using convex lens. Okay, this is a very important thing. If the value of F is positive, then you know that that lens is a convex lens. If the value of F is negative, if the focal length is negative, okay, the value of F is negative, then we're talking about using a concave lens. Okay, so there's a difference here. So the value of the negative doesn't mean that the focal length menjadi nombor negative. No, it just tells us what kind of lens we're using. Okay, and people who are, okay, so people who are in this business, okay, they are either optometrists, I think, optometrist, okay, or the other one is ophthalmologist. If I'm not mistaken now, okay, I may be mistaken, ophthalmologist. People who deal with spectacles, okay, people who deal with spectacles, these positive and negative numbers have a meaning to them. They don't just simply say, oh, okay, your lens is positive 25. Then you're like, adakah negative 25? Okay, there is a meaning to it. Okay, and for the optometrist or the ophthalmologist or the person who does the specs, it's very important, this positive, negative. Because if you use the wrong lens, then you will make the problem in your eye worse. Okay. I wonder how many of you know, like spectacles generally is which lens? Is it convex lens or concave lens? Okay, there is a difference to it. Different lenses fix different problems. Ada orang yang rabun jauh, ada orang yang rabun dekat. Okay, rabun jauh means cannot see far, right? Means short-sighted. Rabun dekat is long-sighted. Okay, you don't use the same lens for the same problem, or for different problems. Okay, convex lens is used to fix one problem. Sorry, I cannot remember, but you can search this. And concave lens is used to fix another problem. So the positive and negative numbers are very, very important because it tells us what kind of lenses we are using, okay, for F. Secondly, the image distance. Okay, when you calculate, okay, if you find that the image distance is a positive number, that means that it is a real image. Okay, now just to remind you, a real image means if this is the lens, okay, the object is here. Real image means the image must be formed over here. See ni mesti image niya. Okay, it must be on the opposite side of the object. If after you calculate, okay, you find that the image distance is negative, then you know that the image is virtual. Okay, which means that sini dia punya object kan, tapi sini dia punya image. Okay, if you remember from last week's lesson, you get this kind of image if you're using a concave lens. Concave is always virtual, VUD, virtual, upright, and diminish. Okay, concave. So you definitely know that the V value has to be a negative value because it is on the same side as the object. Okay, it is a virtual image. Even when, oh dear, okay, even when we're talking about, okay, sorry, even when we're talking about this, remember this, the problem that many of you had. So if you have the convex lens, okay, this is the F, okay, and you put the object over here. Okay, where is the image? The image is very big behind here, right? Okay, this is the image. Okay, it is supposed to be virtual, upright, and magnified. Okay, kalau F di sini lah. Okay, so in this case, here is our U. Okay, our U will always be positive. But because the image is on the same side as the object, our V value here has to be negative. Because the negative tells us whether it is a real or virtual image. Okay, so please take note about this. Positive and negative values for F and V are very important because they tell us characteristics about the image. Is it real? Is it virtual? Okay. Of course, if you want to know whether it is magnified or diminished, then you have to count the linear magnification. Okay. So let's take a look at a certain problem which involves thin lens formula. This question is similar to the one in your textbook, but it is not the same. Okay. So a thin convex lens, okay, the first thing that you should notice is the word convex lens. Convex lens means this focal length F is positive. Okay, it's a positive number because it is a convex lens. Now determine the characteristics and the position of the images formed and linear magnification when the object distance is 20 cm. So the object distance is U. U equals to 20. Okay, so this is where it is. So 1 over 10, okay, kita pakai cm saja. It's okay to use cm, no problem at all. Okay, 1 over 10, and it is positive because it is a convex lens, equals to 1 over 20, because it is a U, and we want to calculate 1 over V. Okay. Oh, sorry, I changed slide already. If you cannot see the slide, please let me know, okay? I'm talking about a certain question, okay, and yeah, of course, you guys are very silent, so I don't know whether you can see the slide. So if you cannot see the slide that I have changed, please let me know. Okay. So when we calculate this, I move the 1 over 20 across. I get 1 over 10 minus 1 over 20. And I'll get 1 over V equals to 1 over 20. Now, untuk mendapatkan V, I just flip the whole thing over. Okay, saya kasih naik V pergi atas dan 20 pergi atas. Since both are 1, no problem. So V equals to 20 cm. And it is positive number. So V positive means the image is real. Okay. Now, if the image is real, okay, you have to also know that it is inverted lah. Okay, this one, this is pretty easy actually because there's only 2 cases. Kalau convex lens, there are only 2 cases where the image is upright. Okay, the image is upright only when it is less than F. Okay, it is no, it is at F or F. Sorry, when U equals to F or U is less than F. These are the only 2 cases where the image is upright. Other than that, it's always inverted. Okay, color convex lens lah. So if take a look, U is more than F, then definitely inverted. Okay, no problem. Same size, you have to count the magnification. So M equals to 20 over 20 because you got the 20 from the first U, and then the V is 20. So 20 is 1, means it is the same size as the object. Okay, and this is how we use the thin lens formula to determine whether the image is real or virtual, to determine the object image, the image distance, and also to determine the size of the image. Okay, whether it is same size ka, bigger ka, smaller. Okay, so all these things we combine together to tell us the characteristics of the image. So the only one you actually have to memorize lah. Okay, I know that some of you already memorized everything, very good. Okay, the only one actually you have to memorize is where is it inverted and where is it upright. For convex lens, there are only two cases where it is upright, where u equals to f or u is less than f. Okay, but in this case, we find that u is more than f, so no problem. As long as u is more than f, then it will always be inverted. Okay, right. The second question is, if the object distance is 15, okay, which is here. So we use the same thing. Convex lens positive 10, but now the object distance is 15. So when you calculate, you get 1 over 30 because 1 over 10 minus 1 over 15, okay, equals to 1 over 30. So when you flip it over, bila kau terbalikkan, kau akan dapat V sama dengan 30. Still positive. Okay, still positive. So if it is positive, then you know that it is real. Okay, and since U is still bigger than F, okay, U adalah lebih besar daripada F. 15 more than 10 bahkan. So it is inverted. Then when you calculate the magnification V divided by U, you find that it is 2. 2 means that it is 2 times bigger than the object. It is magnified. Okay, so that's how we use the thin lens formula to determine the characteristics and the position of the image. Okay, very, very important formula. It is, yeah, it is so important. Okay, moving on to the next slide. The next slide I'm showing now is question 2. Once again, if you cannot see this slide, please let me know by turning on your mic. Okay, I cannot read your comments, guys. Whatever that you're chatting, saya tidak nampak because right now I'm just talking to a slide. Okay, so yeah. So question 2, this slide is question 2. An object with a height of 10 centimeters. Now this is height, 10 centimeters, is placed 50 centimeters from a concave lens with a focal length of 30 cm. Okay, concave and focal length 30 cm means our F is negative 30. Sebab negatif ini adalah untuk concave lens. Our 50 centimeters is U. Okay, U is 50 centimeters. Okay, so no problem. Okay, determine the position and size of the image form, set the characteristics. Now, characteristics is definitely the simplest because concave lens, no matter where you put the object, okay, the characteristics is the same, which is VUD, virtual upright diminish. Okay, tidak payah fikir pun because concave lens all the same. Okay, the only difficult part now is we have to calculate the deviation lah. So let's substitute everything in. 1 over negative 30 equals to 1 over 50 plus 1 over V. Okay, so I bring the negative 30 across, or no, never mind. I bring the 1 over 50 across. So I get negative 1 over 30 minus 1 over 50. Bila saya kira ini, saya akan dapat negative 4 over 75. Okay, so how do I get this V? 1 over V equals to negative 4 over 75. When I flip it over, okay, I will get V equals to negative 75 over 4. Bila saya kira 75 bahagi 4, saya akan dapat this one. Negative 18.75 cm. Now, V negative bermaksud satu, dia adalah virtual. Okay, dan kedua, dia adalah in front of the lens, which is why this sentence is here. Image is 18.75 centimeter from the lens, okay, in front of the lens, not behind the lens. Okay, and we can calculate the height, okay, by using the linear magnification formula twice. V over U equals to HI over HO. Cuma yang 18.75 ini kita tidak payah pakai sudah negative. Okay, because negative magnification doesn't mean anything to us lah. So we just throw away the negative number. We use 18.75 divided by 50, V over U. Sama dengan the height image yang kita mau cari, it over 10. Because the original height is 10. And we find that it becomes diminished lah seperti yang kita jangkakan. Dia memang diminish 3.75. Okay, the image will always be smaller than the object for concave lens. Okay, so notice that with these two formulas, actually, we can actually determine a lot of things. Okay, we can determine the position, the size, we can even determine the height. Okay, of course, this is an example lah. The previous one was a lot more simpler lah. Kita just mau cakap saja. Okay, but this is a very complete can say this is kind of a complete answer lah, because you totally, immerse yourself in the formula to explain, okay, the characteristics of the image form. Okay, so this is one of the usage. This is the main usage lah, okay, of thin lens formula, which is actually a very simple formula, but it is the only thing that may be a little bit tough is that you must remember which is the positive F and V and which is the negative F and V. If you can remember that, then it's very simple. Okay, all you have to do is just place it correctly and make sure that there is a negative where it is negative. Kalau tiada, kita anggap positif sajalah. Okay? Alright. Now, this formula, 1 over F equals to 1 over U plus 1 over V. Okay, I want to talk about this formula a little bit, okay, and I want to just let's say this formula, okay. Let's say if I change the positions of the formula a little bit, okay. Let's say if I want the kepala rumus to be 1 over V instead of 1 over F. Saya tidak mau 1 over F lah. Okay, let's say I want it to be 1 over V. So what I will need to do is I will need to bring the 1 over U across. So I will get negative 1 over U plus 1 over F. Sorry, I changed slide already. Once again, if you cannot see the new slide, let me know. And I'm writing a lot of stuff lah. So 1 over V equals to negative 1 over U plus 1 over F. Okay. You know what? I'm going to do a new slide over here just to let's see. Okay. So okay. Okay. Yeah, I know. I should have prepared this a lot earlier. Okay, fine. Let me do this. Okay, right now I'm showing you a slide where there is a bunch of candles down here and only 2 formulas pada slide itu. Can you see it? Can you see it?
Yes.
Okay, thank you. Oh, I love it when you turn on your mic so suddenly and then after that shout into the mic, yes, like that. Terus saya punya telinga pun menjadi pekak. Do you guys know that like 2 minutes before our class began, my specs cracked. I also don't know, suddenly I was just sitting down here doing nothing, my specs just suddenly cracked by itself. So actually you see, there's a hole over there lah. So I'm like, apa ini? Yeah, some kind of bad luck lah. Okay, so anyway, so this is the formula that we used to, and if I adjust it, 1 over V equals to 1 minus 1 over U plus 1 over F. Okay, now, if you remember, okay, if you remember from studying at maths with who's your MS teacher, Cikgu Lim, Puan Lim. Okay, now if you remember linear law, okay, if I were to do this as y equals to mx plus c, okay, I can conclude that if I draw a graph, okay, if I draw a graph of 1 over v against 1 over u, I will get a straight line. I will get a straight line where it is a negative 1 gradient. Okay, the gradient will be negative 1 from here. Y equals to mx plus c. And this value over here is 1 over f. Okay, dan saya boleh menggunakan nilai ini, the y-intercept, I can use this y-intercept to find the focal length. Okay, so this value over here equals to 1 over f, so I can find the value of f by using the graphical method. Okay, we call this the graph method lah. And of course, you know that whenever we talk about graph method, means we have to talk about an experiment. Okay, so please turn to page 259 in your textbook, because I want to talk about the experiment that we need to do also. This is, yes, I know this is probably the last experiment, okay, but you need to do this experiment as well. Okay, page 259, I am now showing you the textbook on my screen. Can you see it? Can you see the textbook?
Yes.
Okay, thank you. Nice and lemah lembut betul dia punya yes gitu. Okay, so this is the experiment. Okay, for two aims. We want to study the relationship between object distance and image distance. Okay, for a convex lens. Okay, we're very specific. We talk about convex lens only lah. And secondly, we want to determine the focal length of a thin lens using the lens formula. Okay, if you remember from this one I see, this is how we determine the focal length. Okay, besides using the lens formula, we can also determine the focal length by finding the y-intercept of the graph 1 over v against 1 over u, and then kasih sama dengan 1 over f. Okay, so this is the hypothesis. When we increase the object distance, the image distance decreases. Okay, and this we found to be true. Okay, if you, yeah, so I'm going to kind of jump all over the place now. Now I'm showing you this one, this one now. When we increase the object distance, okay, fine. When we increase the object distance, we find that the image distance, okay, becomes nearer and nearer. Okay, except for, okay, this case now only applies as long as your object distance is bigger than f, because we know that at f, the image becomes at infinity, and then beyond f, it becomes there lah. Okay, so this one doesn't apply. But we find that after f, the bigger your object distance, okay, kau makin besarkan, you find that your image distance will be smaller. Okay, and that's the hypothesis that we want, that you've already proven last week. Okay, the bigger the object distance, the smaller the image distance, except for, two cases lah, where it is virtual. Okay, so okay, I'm once again showing you the textbook. So that is the hypothesis that we want to study, which you should be able to prove lah. Okay, because you're using the you're using the virtual this one anyway. Okay, the second one is to determine the focal length, and this one you can only determine by using the graph. So these are the variables, apparatus, blah blah blah. I want you to use this setup. Okay, although we're going to do it virtually, but this is how the actual setup is lah. Okay, you put the object over here, you do the convex lens over here, and then after you put a white screen. The idea is to capture the image on the white screen. Okay, so switch on the bulb and start the experiment with object distance of u equals to 15 cm. Okay, but over here, if you notice the convex lens kan, the f equals to 10 cm. Okay, so I want to talk about this. I want to talk about the f that you're going to use, and then the values of u. Yang penting kamu ada 5 nilai u. Okay, object distance. Ada 5 image. 5 object distance. Okay, I am showing to you once again the interactive. Okay, please tell me if you cannot see the interactive. So the first thing is this lah. Okay, our focal length, the preset focal length in this one is 20 cm. Okay, if you want to change it to follow the textbook to 10 cm, can just go ahead and change it lah. Unfortunately, on my this one is a little bit rough lah, so I cannot really get it at 10. Okay, but actually for me it doesn't matter. Okay, it doesn't matter because you can set it at 20. You can tinggalkannya at 20, which now I cannot set it as 20 anymore. Okay, but let's say you want to use, you want to use a focal length of 18.8 cm. No problem. Okay, the most important thing now is your object distance. Okay, must be 5 values yang berlainan. Okay, your object distance must be 5 different values yang berlainan, okay, yang mesti lebih daripada focal length. This is the only important thing. The object distance must be more than the focal length. Okay, because once you have the object distance, then you can get the image distance. Tinggal kamu tetapkan saja 5 object distance and ambil dia punya bacaan. You don't even have to look at the drawing anymore. Okay, I want you to take this value, the object distance, and this value, the image distance, 99.4. Okay, contohnya lah, contohnya. Okay, but the focal length you have to set, and you need to remember the object must always be beyond f. Jangan kurang daripada f, must be beyond f. Okay, now I suggest that you take 3 values over here and 2 values over here. Okay, 3 values over here and then 2 values over here. Okay, doesn't matter. Of course, dia lebih cantik kalau dia adalah nilai seperti begini. Object distance 55. Okay, then the image distance tak kisahlah. You memang have to ambil apa-apa yang ada. But preferably your object distance should be nilai-nilai yang cantik lah. If you can adjust the object so that the object distance is very nice and sekata. Okay, for example, 20, 30, 40, 50, 60. Wah, itu sangat cantik lah. Okay, if you can do that, it's even better. Unfortunately, on my laptop, I cannot. Okay, it's very annoying one. If I do on my laptop, I will get all these strange values lah. Yeah, I know. Okay, but some of you I saw when you were doing the linear magnification exercise last week kan, cantik-cantik kau punya object distance semua. Okay, so can, no problem. Okay, is as long as you can adjust lah. But all you need to do is just 5 values of object distance and 5 values of image distance. That's all you need to take down. Okay, if you can set your object distance as cantik as possible, that's even better lah. Okay, I'm going back to the textbook, people. Can you see the textbook?
Yes.
Okay, so once you have done the 5 values of u, okay, yang saya cakap tak perlu ikut ini. Okay, you can set your this one. So remember the focal length you can change. If you change your focal length, jangan salin ini 10. Okay, guna focal length yang di dalam virtual experiment. And then the u yang pertama also you have to change. Okay, depending on your virtual experiment lah. U yang pertama, kedua, ketiga, keempat, kelima yang ditunjukkan dalam procedure ini, you have to change. And also the U inside your table. Okay, it's okay to change, no problem. Okay, once you calculate the U and you calculate the V, then you have to calculate the 1 over U and 1 over V. Okay, now I want to remind you this, 1 over U is not just 1 over 15, okay, you have to give it to me in at least 2 or 3 decimal places. So let's say your U is 15. Contoh lah, your U is 15. So 1 over 15 is 0.0667. Okay, jangan juga kamu tulis 1 per 15. There is no way you can plot 1 per 15. Okay, ya, sepak muka ni siapa yang tulis 1 per 15 kan, memang. Okay, so please do this in decimal places. Okay, once you are done with this, then you plot a graph of 1 over U against 1 over V against 1 over U. Okay, this time very good, one graph only lah. Okay, and as I said before, if you remember this is what you expect the graph to be like. Okay, sorry, I'm showing you the PowerPoint slide again. Yeah, I'm jumping a lot here and there. That's why you have to tell me if you don't see when I jump. I jump to the PowerPoint slide. This is the graph that you're expecting to see. It is a decreasing linearly graph. Okay, we expect to see this graph. Okay, so tolong, you have to expect this kind of graph lah. Okay, which means that you have to use best fit. Okay, memang you will get weird values, but you should try to get a best fit value. And you should also be able to get a y-intercept. Mesti ada pintasan pada paksi y. Because you need this value to calculate the 1 over f. Okay, shifting back to this one. So number 1, determine the gradient of the graph M. Okay, now according to our thin lens formula, the gradient should be equals to -1. Theoretically, it should be equal to -1. Let's see who can get the nearest value to -1. Okay, siapa yang dapat -1 cun-cunkan memang saya tepuk tangan lah. Okay, now determine the intercepts for both axes. Okay, that means you need to determine the intercept for the y-axis and the x-axis. Using the lens formula and the graph plotted, okay, determine the focal length of the lens in this experiment. Okay, so this is where, I'm going back to the slide, this is where ini yang saya cakap ini. You have to write this down. Y equals to mx plus c, and if I adjust the thin lens formula to this one, I'll get 1 over v is this one, 1 over u is this one. So that means your y-axis, okay, y-axis is 1 over v, x-axis is 1 over u, my gradient is -1, and my y-intercept is 1 over f. Then you determine the focal length from there. Okay? So, once you have determined the focal length, okay, I want you to tell me whether your calculation punya focal length and the focal length yang kamu tentukan daripada awal eksperimen itu is the same. Okay, that is what I want to see. Then after that, you just write the conclusion. Okay, conclusion, as I said, is from the aim. Number one, to study the relationship between object distance and image distance. Okay, this is definite when the object distance increases, this one. Number two, to determine the focal length of a thin lens formula using a lens formula. Okay, so you have to tell me the two conclusions. Number one is what is the relationship. Number two, what is the focal length of the lens according to your graph. This is very important. Okay, according to your graph. Then lepas kamu cakap according to your graph, okay, then you tell me whether there is a difference from your graph value and the real value yang kamu tentukan. Okay, and if there is a difference, tell me why there is a difference. This is a slightly more difficult experiment. That's why there's only one graph. Okay, but the conclusion is a little bit tough. Okay, I'm going to say it here again, and if you need to refer to this recording, go back to this recording. Okay, how to write the conclusion. Now, there are two aims to this experiment. The first aim is to determine the relationship between the object distance and the image distance. Ini tiada masalah. Kamu salin je balik ini hypothesis because our experiment already proves that. Now, the second aim is difficult. The second conclusion, you want to determine the focal length of a thin lens using a lens formula. In your interactive, you may have already said, contohnya in this interactive, I have said that I'm showing the interactive now. In this interactive, I set my focal length as 18.8. Okay, that is the one yang saya tulis dalam procedure. Okay, that's the one that I write in the procedure. But let's say lepas kau lukis-lukis graph semua kan, you find that from the focal length and the grade and the intercept yang kamu kira, you find that your F is not 18.8. Let's say kamu dapat, lepas kau kira-kira kan, kau dapat 16.8. Contohnya lah. Okay, original daripada virtual is 18.8. But bila kau kira dalam graph, kau dapat 16.8. Okay. I want you to just tell me, okay, don't tell me the reason. I want you to just tell me how much of a difference there is. Okay, the difference from the theoretical value. So this is how you would write the second conclusion. Okay, let me see. Okay, so this is how you write the second conclusion. I give you a contoh lah. The second conclusion is from the graph, okay, the focal length is, let's say saya kira 16.8 cm. Okay, there is a difference, okay, of 2 cm from the theoretical value in the experiment. Okay, that's all. I don't have to give me the reason why. Usually in cases like this, I will ask for the reason why, but that's a long story altogether lah. So let's not talk about the reason why. Okay, so let's say yang kamu kira daripada graph 16.8, but the actual value yang saya tentukan daripada virtual experiment is 18.8. So there's a difference of 2 cm. Okay, so I just want you to write the difference. Tell me what is the difference from the theoretical value. Ini nilai secara teori. Ini nilai secara practical. Means daripada graph kau sudah dapat ini nilai. Okay, so you have to tell me that there is a difference. If there is a difference, if there is no difference, wow, saya tepuk tangan. Okay, yeah, if there is no difference, means your theoretical value and your graph value is so cun-cun kan. Okay, next year saya belanja makan lah. Okay, yeah, betul-betul. If there is no difference, if you really can do, if you can manipulate in such a way that you get no difference at all, okay, then next year bila kita balik ke sekolah kan, then I will belanja makan lah. Cause it's like, wow, super, super hebat. Okay, very, very, very super hebat. Okay, so that is the work number one for today, which is this experiment. Sorry, I don't know why I keep going back to this one because I want to see what else that I. Oh, okay. One other thing to do today, another homework. Okay. So this is the worksheet that I gave you yesterday. Can you see this worksheet? Ini, ya, ini muka depannya, the one with the light bulbs. Can you see this? Sorry, can you see the worksheet, people?
Yes.
Okay, thank you. So this worksheet, most of it actually kita sudah cover lah. So you kind of got it a little bit late. But I want you to go to this page, page 8. Okay, page 8 on this one. I want you to answer these two exercise questions. Okay, these two exercise questions and hand it to me, okay, in your Google Classroom. Okay, so as you can see, this image formation by lenses, so far only one person has turned in, okay, because, you know, I said that you can hand it in by next week. This is yesterday's work. So this is the thin lens formula. Okay, please complete page 8 of your worksheet and then just scan your work and hand it in. Okay, just to remind you, there are still another 8 more people that haven't handed in the previous homework and another 4 more people, okay, from here. So please get around to doing this lah. Guys, since we're not going to be meeting anymore this year, kita tidak akan jumpa lagi kan, I expect you to complete this work and to hand it in, okay, by any means necessary lah. Okay, now I understand that some of you have slight problems with internet, okay, but that should not be an issue lah. Okay, if you have a problem with your phone, for example, okay, then please use somebody else's phone. Find a way to make sure that you can hand in your homework. Because I don't want to go into next year dan saya masih lagi menagih kerja daripada tahun lepas. Okay, I want this year work to be completed this year. Okay, so please find every means possible to do it. Okay, this experiment, okay, so before I end, so the experiment that you do, this is what you need to take a photo and show to me. Some of you, the previous experiment, you still haven't shown to me. Some of you, since last week, you say you want to upload the graph, right? Until today, still uploading lah. So it's like, oh, okay. Ada juga orang yang sampai 2 minggu tu dia mau upload satu graph. So I'm like, okay, whatever lah. Okay, but try not to this one because ini eksperimen semua akan dikumpul. Okay, so you need to make sure that you have it. Okay, now this experiment, what you need to show me. Okay, what you need to show me. Show me the table. Okay, show me the table. Show me the graph. Okay, show me the graph that you draw. Okay, and then show me your analysis and conclusion. Means saya mau tengok kamu punya pengiraan dan saya mau tengok kamu punya conclusion. So when you snap a photo of your experiment, okay, you need to show me these 3 things. Okay, show me these 3 things when you snap a photo. Okay, now one last thing before I open to questions. Apa yang akan berlaku kepada kamu punya eksperimen semua? Okay, what is going to happen to all your experiments and everything? Okay, so far we have done 2 virtual experiments. Kalau saya tidak silap, okay, we have done 2 virtual experiments, which is actually the last 2 in your in your syllabus. Actually, there's one more, but we cannot do it this year. Okay, we have to do it next year. So these 2 experiments if you want, you can actually start doing it now. You actually need to scan the entire thing. Okay. No, wait, let me see. Apa ketetapan yang... No, you know what? I want you to keep the experiments. Okay, I want you to keep the experiments. You know what? I'm going to stop presenting because I have already... I want you to keep the experiments, okay? Because I realize that your white file is in me. Your white file is with me in school, so it's okay. I want you to keep the experiments until next year. Okay, and don't lose the experiments. Okay, jangan kamu hilangkan the experiment. Otherwise, you have to do it all over again. Okay, and you know how difficult it was to do. So please don't lose the experiments. Keep it somewhere safe. Okay, and then put it into the file next year. Okay, I won't ask you to scan lah, because since you've already taken photo to show me your experiment, so I won't ask you to scan the work again lah. Okay, so as long as you've done the experiment, then saya akan anggap yang kamu akan simpan the experiment untuk dimasukkan ke dalam file pada tahun depan. Now these experiments are important. You cannot lose a copy of the experiment report because it goes into one part of your exam syllabus lah. Okay, so if you don't know your syllabus, there is a set of experiments kan yang kamu wajib ada laporan. Okay, so the worst thing that can happen to you is if you lose all the laporan, means that you have to do all the reports all over again, which is a big waste of time. Okay, so please avoid from losing the experiment report. Keep it in a file somewhere and then say, okay, 2021, bila saya balik pergi sekolah, saya mesti kasih masuk ini dalam file warna putih. Okay, which is most of your files are with me lah. But some one or two random people that the files tidak kena hantar dengan saya. Okay, so I noticed that there are some people that masuk keluar. So I'm going to assume that there are 24 people here today because from the beginning I noticed that our number is between 24 and 25. Now there's 24. Termasuk saya is 24. That means there's 23 of you. Okay, but just now there was 25. So, oh no. Now there's 24. Correct. There has always been 24. So that means there are 23 people here. So there are a couple of people not here. I hope that they can see the video lah. Okay, because today the work is pretty important. Okay, any questions that you want to ask about the work that you need to do? Today got quite a lot of work. Yeah, I know. This week there's quite a lot of work, and I hope that you can finish everything by this week, before next Tuesday, because next week kita mau cakap pasal itu Google Sites, the one that I talked about at the early of the chapter. Okay, so please try to finish everything by this week so that next week you can only have just focus on the Google Sites lah. Okay, those of you who've already started doing the Google Sites, go ahead. But officially next week, I want to start the Google site for this chapter. Okay, any questions about our work today? It's quite a lot now, I know. From yesterday and then today there's two work. One is the exercise and then one is the experiment. Yesterday is the ray diagram. Okay, so yeah. Any questions from anybody? Okay, well, if there's no questions from anybody, since, well, I guess there's no questions now. I'm going to stop recording.